right triangle trigonometry. I will start with a Pythagorean known as 3, 4, 5. So if you have a right triangle, sides are like 3, 4, 5, and then 3 square plus 4 square equals 5 square. This is known as Pythagorean. So we'll use this concept to find some values for 6 trig functions. So say that you are given a right triangle with measures 16, 20, and their angle x. We call it a reference angle. We need to find all 6 trig values for sine, cosine, tangent, and the reciprocals cosecant, secant, and cotangent. Okay, so compare these two triangles. See, this one has 16, 20. This one has 4, 5. Look like is a scale factor of 4. It's a similar triangles. So if you multiply this one by 4, so you get 16 and get 20. So this must be 12 then. Other way, you can just say 20 squared minus 16 squared and take the square root. That will give you 12. But it is good to use some reference triangle if possible. So now sine x will be opposite over hypotenuse. That's 12 over 20. Or you can just reduce it, get 3 over 5, and you can compare with the reference triangle here. Same way, your cosine will be adjacent is 16 and hypotenuse is 20, and simplified version is 4 over 5. And your tangent is, you know, from SOHCAHTOA, so opposite over adjacent. Opposite is 12 and adjacent to the reference angle x is 16. So you get 3 over 4. You are done. Now cosecant, secant, and cotangent, those are the reciprocals. So sine has reciprocal cosecant, so it will give you reciprocal value 5 over 3. Secant gives you 5 over 4, and tangent gives, from tangent you get cotangent 4 over 3. You are done for this problem. We take the second example. Say that you are given a point 8, negative 8 in the Cartesian system. So if you plot this one in the Cartesian plane, you get a point in the 4th quadrant. So keep it in mind that we are looking for all 6 trig functions in 4th quadrant. So I make a right triangle, and then as a reference angle I pull this triangle here. So sides I'm just taking 8, 8, and then with reference angle theta. You don't have to take negative because we are taking care of this one in the 4th quadrant. So then the hypotenuse will be 8 radical 2. You can remember from your high school that if you have sides like equal, this isosceles triangle, right triangle, so then hypotenuse will be radical 2 times of the sides. Or you can just say 80 squared plus 80 squared and the radical sign. Simplified version will be this one. So I'm taking the reference triangle now. So you divide by the scale factor 8. So I get 1, radical 2, and 1. So you can use those values now for sine, cosine. So your sine theta, as you know, we are in the 4th quadrant, must be negative. So you get 1 is your opposite, and your hypotenuse is radical 2. So you get this. And rationalize the denominator, multiply numerator, denominator by radical 2. So you get this answer. Cosine theta the same way. You have adjacent over hypotenuse, and cosine must be positive in the 4th quadrant. Tangent is negative. You can take from original triangle or you can take from here, doesn't matter. So you get your answer negative 1 because it is in the 4th quadrant. Now remaining other 3, and you know sine, cosine, and tangent has reciprocals like cosecant, which is opposite of reciprocal of sine. So if you reciprocate this number to radical 2, you reciprocate this number, you get radical 2. Sine has a negative, so cosecant has negative. Secant is positive because cosine is positive. Cotangent is negative because tangent is negative. So you are done. Next, we see how to find the exact value of some trig functions. So cosine 120, I split this one as 180 minus 60, and why it is, you will see. Just say this is your 120 degree angle. what is the coterminal? Sorry, I'm not saying coterminal. What is your reference angle for this? The other one is here, 60 degree. So you can easily say 180 minus 60. So 180 will disappear, and you just see where is your terminal site. It is in the second quadrant, must be negative. So you are dealing with cosine reference angle 60. So that gives you negative half. Next example. I'm dealing with secant 570 degree, and C, we are not comfortable with secant. So convert this one to cosine is 1 over cosine, and then deal with cosine. Now 570 degree, how it is this, I want to show you in the next. Just divide your 570 in terms of 180. So you can go 3 times 540, and remaining is 30. And clearly we know 30 degrees is my reference angle. So I can use 3 times 180 plus 30, that is my 570. So then I will just deal with the reference angle 30, and you need to check where is the terminal site. It is in the third quadrant. So cosine is negative in the third quadrant, so you get a negative sign, and you just get the value of cosine 30, which is radical 3 over 2. And when you reciprocate it, you get 2 over radical 3. Rationalize the denominator with radical 3 here and here. So 2 radical 3 times radical 3 will give you just 3. So you are done. Next we'll take angle with radian measure. So you have 29 pi over 6. So we'll deal with 29 and 6. Let's look at, divide 29 by 6. You get 4 times, usual division, 24. 5 is coming out. So when I write 29 pi over 6 as 4 pi plus 5 pi over 6, this one is not exactly my reference angle, but you can solve this problem using unit circle. I want to show in a different way. I'm not happy with this angle here, not a reference angle, so I want to go with in terms of reference angle. We do the different way division. Take 6 5 times is okay. It is overestimation. Gives you 30, but when you subtract is negative 1. It's still okay. So then you see 29 pi over 6 can be written as 5 times your pi, and then minus pi over 6. So that exactly we have here. Now I can forget about 5 pi, because this is just giving me rotations and taking me to the reference angle. Now let us look at the diagram. Where is my terminal site? Okay, so you can see this is your pi by 6, because 29 pi over 6 goes with some rotations, then it goes here. So that the reference angle is the remaining one, which is pi by 6. And you can see this comes from here, from the remainder. Negative 1 over 6, which is pi times. So you get this is your reference angle. And you are done for this problem. Now, just quickly reminding you the transformation. You have y equals a sine of bx minus c plus d, and you can compare this with its parent function, y equals sine x, and same way with cosine x. So both the cases, your amplitude will be this guy here, a, then your period will be 2 pi over b, and your phase shift will be c over b horizontal, and the vertical is outside, which is d. Now we want to work on these two problems, find all the information, and it's very easy to see. Amplitude is 7. Forget about the negative sign. You are looking at the length, and then your period is 2 pi over, your b is here, f, just pi. So 2 pi over pi is 2. Phase shift will be, now c is negative 3 pi. So c over b, and that gives you 3 negative, which is horizontal shift. And we do not have any vertical shift here, no added term outside. Then we have, since you have a negative sign here, the graph has a reflection over x-axis. Same way you can deal with the last one. And you remember in this case, there is no sign change, no negative here. So we don't see any reflection on over x-axis. And you get all other stuffs. And we're done. Thanks.